Here we have the discussion of the distance time graph and velocity time graph. If you want to calculate the speed and acceleration with the help of your distance time graph dt and the velocity time graph vt, then you have to understand the slope of these graphs. You have to understand the area of these graphs, and these two will give you the idea of the physical state of the body as well. First of all, you can discuss the distance time graph. If we have the distance time graph, then you know that as far as the definition of the velocity or speed is concerned, this is the distance divided by time. So it means that over here, the gradient represents, when you will consider the distance time graph, the gradient represents the speed. On a distance time graph, the slope steepness tells you how fast the object is moving. Yani, the gradient will tell you that what is the speed of the body. So here you can see that the body is moving up and the body is moving in this way, that the gradient is you can say a steeper gradient or a steeper slope. So you can say that the body is moving faster, but with a uniform velocity. The velocity is not changing. Distance is changing here, but the velocity is not changing. Why? Because the slope is constant. So the slope is steeper but constant. So be careful of this fact. When you will come to this part of the graph, you will say that the body is moving with zero velocity because the gradient over here is zero, slope is zero. Flat slope means the zero slope, zero gradient, and it means that the body is not moving. So here you can say that the horizontal lines means is stationary. A flat situation, a flat horizontal line indicates, what indicates over here? Indicates the object's distance is not changing. So simply the speed is zero. Remember one thing, that in this picture or in this diagram, the road you feel is not a road, but here you are actually representing this gradient over here. So the slope is a big slope over here. The slope is a steeper slope. Here, the slope is a flat one and the body is not moving. But when you are considering this situation, here you can say that the gradient is increasing. So, gradient is increasing means velocity is increasing. And if you will consider this way, then the slope is decreasing. It means that the body is decelerating, yani velocity is decreasing with time. So when you will show in this way, the curves show changing speed. Upward curves indicate acceleration, while the curves leaving off indicate deceleration. As I have written over here, and I actually you already know that the gradient is nothing but the formula you have here. In this case, you have run time and rise is the distance covered. So obviously the gradient is giving you nothing but the velocity. The line shows, the flat line shows that the gradient is zero, and the gradient is zero means we are actually dealing with this situation. On the other hand, if you will consider the speed time graph, then what will be the situation over here? You know that the acceleration is rate of change of velocity, and when you are talking about the rate of change of velocity, obviously over here you can say and see that the gradient represents gradient of what? Gradient of speed time graph represents acceleration, because you can say that the velocity is changing. Like suppose if you are considering this situation, that the velocity is zero over here, and with the passage of time the velocity is increasing uniformly. So over here you have the maximum velocity. So you will calculate the gradient, and this gradient will give you, or the slope will give you the acceleration. So with the help of the velocity time graph, we can get this acceleration of a body. The slope of the speed time graph shows how much speed is gained every second. Any change of velocity we will consider as far as the gradient of the speed time graph or velocity time graph is concerned. Like suppose in this case, if you will compare this graph with this one, then both these lines are straight, but in this case, we have another interpretation. The body is moving with 20 meter per second and the body is not at rest. So over here, if you have this situation, then what you will say that the body is not at rest, slope is zero, means that the acceleration is zero, but the body is moving with constant speed. So this is very, very important that in this case, the flat line means the body is moving with the uniform speed. The body is not accelerating. But in this case, when we are considering the flat line like this, suppose, then obviously the body is not moving at all. So here we have the unlike DT graph, a horizontal line here means the object is moving at a constant speed. The body is not acceleration, body is not accelerating or decelerating. Over here, if you have this turning, so it means that the graph is decreasing. So graph decreasing means the slope is decreasing. And when the slope is decreasing, it means that you are talking about the decrease in velocity. So this is nothing but the deceleration. So the initial value, suppose, is this one, the higher value, greater value, and finally, when you have this time, suppose this time is t1, this time is t2. So here you have initial velocity, here you have zero velocity, final velocity. So what will be the situation? The body is decelerating. On the other hand, if you will consider the area of the velocity time graph, then the area is nothing but equal to the distance traveled. Why? Because you know that S is equal to V into T, velocity into time. So what you will consider, what you will say that the area under the curve of Vt is nothing but the distance traveled. Over here, like suppose in this case, you can say and see that the area under the curve is nothing but a triangle. And what will be the area of the triangle? Given by half t into v. Yani this is the time over here, and as far as the mathematical formula is concerned, this is half a into b. But what is a? This is nothing but time. What is b? This is nothing but velocity. So remember this thing that the area under the curve in this case is nothing but half vt. Another interpretation of this half vt means that at this point the velocity is zero. At this point, this has a particular value, like suppose 20 meter per second. So it means that if you will consider the velocity, this will not be the velocity, uniform velocity, but here you have the change in velocity, uniformly change, but change in velocity, and ultimately you can say that the zero was the initial velocity, v is the final velocity. So that's why we have divided your 0 plus v divided by 2, and this is actually giving us the half vt. So this is the physical interpretation, and here you have the mathematical formula, half v into t or half t into v. So this is what we have as far as the speed time graph is concerned. This is a brief explanation. A little detail we will discuss later on, and keep in touch. If you are new on my channel, subscribe this channel, so when I will upload another video, detailed video, you can see, and this will give you a better understanding, inshallah. But obviously, for the revision, a quick revision, or you can say the speed time graph and distance time graph at a glance, this is what we have here. So if you like this lecture, share with other as well, and inshallah see you in the next discussion. Till then, Allah Hafiz, take care.